Hi, in this lesson we're going to be working with polynomial operations. And before we begin, we first have to learn a few rules or remember a few rules that we did in the past. The first rule is what happens when you multiply two bases with exponents? What do you do to the exponents? You're supposed to add them. What happens when you divide them? You're supposed to subtract them. Now those two rules that we learned in the previous lesson are going to be vital in today's lesson. So make sure that when we're working with polynomials, we remember that polynomials have bases that have exponents and those have rules. You ready? Let's begin. In the first problem, they're going to ask us to simplify two polynomials by addition. Now you're going to notice that there's an addition sign in the middle, but there's two parentheses. I always want you to remember that parentheses may incorporate some type of multiplication, right? But you're going to multiply whatever's in front of it. Problem is, in this situation, there's only a 1 in front of it. And if I distribute a 1 to both of these, what do I get? I get the same thing, because anytime I multiply 1 to anything, I get itself. So because of that, I'm actually going to ignore the parentheses whenever I notice there's a positive 1 in front of it. So there's a 1 here and there's a 1 here. So because of that, let's ignore it. So what do? We're just going to simply just drop the parentheses and write the problem out. So it's going to be 4 plus 2n cubed plus 5n cubed plus 2. Now your next step is going to be you want to combine like terms. Now remember, terms are items in your polynomial. So we want to combine terms that look alike. So what looks alike? Bases and exponents that are the same, or simply just constants. Constants are just numbers. So the first thing I'm going to notice is a 4. So I'm going to draw one line under 4. I'm going to draw another single line underneath the number that looks exactly like 4. Not exactly the same, but like a constant. So that's going to be 2. I'm then going to look at my next number. Well, I see 2n cubed. So I'm going to draw 2 lines for that. And I'm going to look for another term that has an n cubed as well, which will be right next to it. My step after that is I'm going to combine the like terms. So for example, I'm going to combine the 4 and the 2 and the 2n cubed plus 5n cubed. But what do? Which one should I go first? Do you remember that last lesson we learned that everything has to be in standard form? Standard form was the highest degree to the lowest degree, or a constant. So in this situation, my highest degree is a cubed. So because of that, I'm going to combine those two. Now when you combine them, you simply just add the like terms. So ready? 2 plus 5 is what? 7. So you're going to write 7n cubed. Then after you combine them, you're allowed to cross them out if you're done with them and you completed that operation already. So my next step is going to be, can I combine anything else in that polynomial? Well, there's a 4 and a 2 that are constants. I know that because I drew a line underneath them. So I'm going to add them. What's 4 plus 2? It's a 6. So since I'm done with those two, I know there's nothing left. So that'd be my simplified answer as well as my final answer. That's it. So when you see that there's a 1 in front of your parentheses, don't distribute the 1, just drop the parentheses and combine like terms. I like to draw lines underneath my terms, so keeping myself organized, but you want to do something that's going to be similar to that so that you can always get the right answer at the end. So for B, I'm going to look for two polynomials, and I'm adding them. So because of that, I'm going to ask myself, what number's in front? And I agree that there's a 1 in front. Do I need the 1? No, because if I were to distribute the 1, what happens? It gives you the same thing, so let's ignore it. So what I'm going to do is I'm going to drop both parentheses, and I'm going to have 5p squared let me write this a little bit better, minus 3 plus 2p squared minus 3p cubed. I'm going to go with the same concept, which is I'm going to combine like terms. So I see a squared. I'm going to look for another squared. It's right here. I see a minus 3. I'm going to look for another minus 3, but I don't see any. So it's only going to be that. I'm going to look at p cubed. I'm going to draw 3 lines because it's my third item or my third term. And I don't see anything else I can combine it. So what I'm going to do is I'm now going to combine the similar terms. But I got to put this in standard form. So I'm going to go with highest degree first, which I know my highest degree is going to be the negative 3p cubed. So I'm going to put that first. And since there's nothing else to combine it, I'm just going to go ahead and cross it off. I'm going to look for my next smaller term, which is going to be p squared, but there's 2 of them. So I'm going to combine 5 and 2. Just combine, don't do opposites. 5 plus 2 is 7. And I'm going to put the p squared right next to it. And then this is going to go ahead and cancel out. Then afterwards, I have a minus 3 by itself. So I'm going to go ahead and just draw minus 3 at the end, cross it off. And since I have nothing else to combine, this is as simplified as it can get. And it's in standard form because it starts off with the highest degree and it goes to the lowest degree. Now, as you're doing these, don't forget the previous concepts. Based on this degree, which is 3, what is that called? What's the name of it? It's a cubic. What kind of polynomial is it? Well, it has 3 terms, so it's a what? A trinomial. So for B, this answer would have been a cubic trinomial. Now I'm going to ask that question every now and then because these are the concepts we still got to remember. Okay? So again, when you see a plus sign, make sure there's a 1 in front of it, and then afterwards distribute it if you want. But notice that when you distribute a 1, you get the same thing, so you're allowed to just cancel out the parentheses, drop everything down. So now what we're going to do for example 2 is we're going to try the same thing. Now it looks like it's a little bit longer. However, it's the same concept. Combine like terms. So if you want to start this video, and if you want to stop this video, see if you can get this one right, stop the video. And then once you get stuck or you get it or you finish the problem, press play so you can check to see if you get this right. Okay. So now for example 2, my next step is going to be I'm adding them because there's a plus sign. So because there's a plus sign, I'm going to ask myself, what's in front of the signs or the parentheses? I notice there's a 1 in front of the first one and a 1 in front of the second one. Because it's 1, I'm not going to distribute, so I'm just simply going to erase them, and I'm going to copy everything down. Now, I know this gets tedious because it's a lot of writing, but the main thing that you want to focus on is to keep yourself organized. Now, I have a situation. If you notice, I dropped a parenthesis, I have a plus and a minus. Which one wins if it's a plus or minus? Negative. So I'm going to put a negative, and then I'm going to copy it down. And then once I copy everything down, I want to be able to combine like terms. So I'm going to look for what things have the same power. So now 9r cubed looks like what? 2r cubed or negative 2r cubed. So I'm going to draw one single line for that so I know I can combine it later on. I'm going to look for the r squared. I'm going to look for another one. I see it at the end. And then I see 11r. So I'm going to draw 3 lines and another r over here. Now, because I already underlined everything, I know that I can just combine from highest degree to lowest. So I'm going to work with 9r cubed as well as negative 2r. When I combine them, it gives me 9 minus 2, which is what? 7. Now, some people are going to be tempted to do the opposite here, but remember, you're on the same side, so just go ahead and combine like terms. After I do that, I'm going to look for my next term, which is going to be 5r squared, as well as negative 8r squared. When I combine it, 5 minus 8, 1 minus 9, so you subtract. 8 minus 5 is 3, r squared, and the 8 is bigger, so it's negative. Once I combine those two, I'm going to cross them off, and I'm going to go to my last piece, which is going to be 11r plus 9r, which is simply going to be 20r. And then once I combine those, I'm done. And this will be my final answer. And that's it. So hopefully you got it right. If not, hopefully you saw where you made a mistake. But you got to make sure you combine like terms. So same concept for B. Pause the video. And once you feel ready, press play. So for B, I noticed that I'm adding 2 polynomials. How do I know there's a plus sign right here? So what I'm going to do is I'm going to ask myself, can I drop these parentheses? Because the number in front of the first one is 1 and the in front of the second one is also 1. I can erase the 1s and I can erase the parentheses. So this is simply going to be k to the 4 minus 3 minus 3k cubed. And then this is going to be a plus minus again, but what do we say? The minus wins, so it's going to be minus 5k to the 4 and then minus 8k to the 5th. Now, once I do that, I'm going to look for like terms. So I notice there's a k to the 4, and I'm going to ask myself, is there another k to the 4? And there is right here, so I'm going to draw one line. I'm going to move to my number, and I notice there's 2 lines. I'm going to ask myself, is there another number? But I don't see one, so I'm just going to draw that one with 2 lines, which means I can't combine it with anything. I'm going to look for the k cubed. I'm going to ask myself, where is there another k cubed? And I hope you agree there's one right here. And then the last term that doesn't have a line underneath is the k5, so I'm going to draw 4 lines here, but there's nothing to combine it with. So now my next step, I have to go ahead and combine those like terms. So I'm going to go from, again, highest degree to lowest degree. My highest degree is a 5. Is there anything that looks like a k to the 5 here? There isn't, because I would have drew 4 lines. So I'm going to write that first, and it's negative 8k to the 5. I'm going to cross that off because I'm done. I'm going to look for my next exponent. Now I have a k to the 4 and a negative 5k to the 4. I don't like combining that because there's no number in the front of k to the 4. So what number should be in front of it? It should be a 1. So when I combine it, it's 1 minus 5, which I hope you agree is negative 4, and then keep the k to the 4, and then cross those out when you're done. I'm going to go to my next degree, which is after 4 comes 3. I see 2 of them. I see negative 3k cubed and positive 6k cubed. So I'm going to go ahead and combine them. 1 negative, you subtract. 6 minus 3 is 3, k cubed, and the bigger number is 6, so it's going to be a positive sign. And then once I'm done with that, I'm going to cross it out. And I'm going to go to my last single item, which is just minus 3, which I already said a long time ago. I can't combine it or anything, so it's going to be a minus 3 at the end. And that would be my final answer. Now, do they get longer than this? Not necessarily. It's all the same concepts. What looks alike can be combined, okay? And then just combine those two numbers in the front by either addition or subtraction. And that's it. So hopefully you got that one right. If not, definitely want to work on that some more, okay? So now what we're going to do is we're going to move on to example 3. Now, example 3, unfortunately, isn't addition anymore, it's subtraction. Now, because of subtraction, we have to understand, well, what do we do when it's subtraction? All we do is simply the same exact thing we did before. What we're going to do first is we're going to look at the sign that's in front of the parentheses. This is technically a positive 1. If I distribute a positive 1, what happens? It stays the same. So I'm going to leave this as 4n minus 3n cubed. But now for the next parentheses, take a look. This isn't positive 1 anymore, it's a minus 1. Now I have to distribute a negative. So what I'm going to do is I'm going to distribute negative 1 to both of these terms. And if you remember, when I distribute a negative times positive 3, negative 1 times positive 3 is going to be a minus 3n cubed. And a minus 1 times a positive 4 is going to be a minus 4n. And notice the difference between this problem and the previous. Now I actually have to distribute something because it wasn't a positive 1, it was a negative 1, which changes my signs. Now, once I distribute negative 1, I just really want you to remember the signs on the opposite side just changed. That's why this became a negative, and this became a negative as well. So what I'm going to do is I'm going to look for like terms. First one is a 4n. I'm going to look for another term that has just an n to the first power, which is the last term. I'm then going to look for the n cubed, and the one right next to it has an n cubed. So when I combine these, I'm going to go in order. Remember, highest degree to lowest degree. My highest degree is a negative 3n cubed as well as a negative 3n cubed. So what I'm going to do is I'm going to technically, am I adding or subtracting? They're both negative. So what does that mean? Two negatives, you do what? You add. So it's going to be a negative 6n cubed, and I can cross these out. Now afterwards, I'm going to combine the 4n as well as the negative 4n, but 4 minus 4 is what? 0. Do not write a 0n. This doesn't say on, okay? 0n will always just cancel out to be absolutely nothing. So my final answer for this one is going to be negative 6n cubed, and I'm done. So the only difference in this problem is now you're going to distribute a negative 1 to everything you see on the right-hand side. So let's try the next one. So I see again a minus sign in the middle. So I'm going to ask myself what signs are in front of the parentheses. This is a positive 1. I don't have to distribute because it's the same thing. So I'm going to drop it down, 3a squared plus 1. I'm going to move on to my next one. I see a negative, so I'm going to put a 1 in front of it, but now I have to distribute the negative 1. So this is going to become minus 4, then minus 2a squared. Now once I do that, I'm going to combine like terms. There's a 3a squared here and an a squared over here. Then next is going to be a positive 1 and a minus 4. So I'm going to go in order from highest degree to lowest. So it's going to be 3a squared minus 2a squared, which hopefully you agree 3 minus 2 is 1. So it's just going to be 1a squared. But what do we say? Do we write the 1? We don't. So we're simply just going to put a squared. And then afterwards, I'm going to cross them off. And then I'm going to combine the positive 1 and the negative 4. 1 minus 4 is what? Negative 3. And then once I cross those off, I have nothing else to combine. So my final answer is going to be a squared minus 3. Now imagine they asked you, hey, what kind of polynomial is this? Well, remember, look at your degree. Your exponent is a 2, so that makes it a what? Makes it a quadratic. Now there's two terms. What does two terms mean? Binomial. So the name of this polynomial would be a quadratic binomial. Okay? Hopefully you got it right. And if you did, good job. If not, definitely got to do a little bit more practice, okay? So we're going to move on to example 4. Now, when you take a look at example 4, it looks more complicated, but it's not. Again, look at the minus sign. The minus sign tells you everything. So because of that, what you're going to do is you're going to look at the signs in front. This is a 1. This is a negative 1. So I'm going to distribute the 1, but are we really? We're not. We're just going to drop it down. So this is going to become 3 minus 6n5 minus 8n4. And then afterwards, when I distribute this negative 1 to everything, the negative 1 changes the signs of everything. So this is going to be a negative times a negative, which is going to be a positive 6n4. And then this is going to be a positive 3n, and then a positive 8n5. Remember, all it does is just changes the signs. So now I'm going to combine like terms. What looks like a 3? What's a constant? Constant is just a number. There's nothing else, so it's just going to be that. I'm going to then look for the n to the 5th. Is there anything that has an n to the 5th? There is, right here at the end. I'm going to go to the 4. I'm going to draw 3 lines because I'm on my third term. and there's two right next to each other that have n to the fourth. And the last one that has nothing is just n to the first. So I'm going to draw 4, so I know I'm only going to combine something that has 4 lines underneath. Once I do that, I'm going to go in order from highest degree to lowest degree. I'm going to work with negative 6 n to the fifth, as well as positive 8 n 5. Now remember, you're just combining them, adding them. Negative 6 plus 8 is 1 minus sign, so subtract. 8 minus 6 is 2, n to the fifth, and since 8 is bigger, it's going to be a positive 5. So it's going to be 2 n to the fifth. Once I combine those two, I'm going to cross it out, and I'm going to move to my next term. My next term is negative 8n4 and 6n4. I'm going to combine those two, negative 8 plus 6. Again, 1 minus sign, subtract. 8 minus 6 is 2. So it's going to be 2n4. But then because the 4 is bigger, because the 8 is bigger, it's going to become a negative 2n4. Once I combine those two, I'm going to cross it off. I'm going to look for my next degree, which is going to be 3n. But I have nothing to combine it with, so it's going to copy down as just plus 3n. There's nothing to combine it with, just copy and paste. And then I'm going to move to my last term, which is 3. But hey, question, what's the sign of 3? It's positive, so you have to make sure you put positive 3. And that would be my final answer. And that's it, I'm done. So again, stay organized and it's going to help you out. So for example B, I would love for you to try it on your own. Pause the video, distribute what you have to, and then press play once you're done. Okay? Okay, so for example B, I'm going to ask myself, what do? I see a minus sign, so I remember I have to look at the signs in front of the numbers. I see a 1 and a minus 1. 1, I don't have to distribute anything, so I'm just going to drop it down. It's 12a5 minus 6a minus 10a cubed. The next one, I actually have to distribute the negative to all of it, so it's going to change the sign. So it's going to become minus 10a plus 2a5 plus 14a to the 4. Notice that every time that you distribute a negative, it's just changing the signs. That's all it is. Now, once you're here, stay organized, combine like terms. This is 1. And look for another one that has an a to the 5, which is right here. My next one's going to be, highest power is going to be 4. I'm kidding, just kidding. I'm going to go back to the front. I'm going to combine 6a and combine anything that has a to the 1, which I hope you agree is the 10, negative 10a. I'm then going to go to the next one, which is 3. And there's nothing to combine it with, so it's going to be by itself. So I'm going to drop it down eventually. And then the last term that's by itself is a positive 14a, and that's going to have 4 lines, which again, I can't combine it with anything. Now, once I kind of organize myself, my next step is to be able to combine like terms. There's nothing that has 4 lines underneath. That means there's nothing that can combine with 14a to the 4th. So all I'm going to do is I'm going to drop it down, and then I'm going to cross it off. I don't have to put the positive sign because it's in the front. And then next, I'm going to ask myself, actually, just kidding. Let's take it back. I don't know if you caught that. I'm actually not going to combine 14a to the 4th first because I notice there's a 5. So I'm going to combine the 5s first, and I have a positive 12a and a positive 2a fifth. So I'm going to combine 2 positive, and that's going to give me actually a 17a to the 5. Hopefully that makes sense, right? So thank you for that. That was a good catch. So now the next problem is going to be combine my next degree, and finally I have the 14a4 that there's nothing alike, so I'm going to just bring it down. And then I'm going to cross it off because there's nothing to combine. I'm going to look for my next one, which is 3 lines, which is cubed, and there's no other lines that match that. So I'm going to go ahead and I'm going to just make sure, and there's nothing. So I'm going to copy and paste minus 10a cubed. I'm going to cross it off. And the last thing I have is a negative 6a as well as a negative 10a. They both technically have a negative 6 and negative 10. They're both negative. So 2 negatives, you do what? You add, but keep the sign. So it's going to be minus 16a. There's nothing else to combine. So this will be my final answer. Now, if I wanted to name this polynomial, my highest degree is 5, which is called what? Quintic. And then because there's 1, 2, 3, 4 terms, that's called a polynomial. So then what's the name of this polynomial? It's called a quintic polynomial. And that's how you get your answer. So subtracting 2 polynomials is the first time that you actually have to physically subtract and distribute a negative, which just changes the signs. Okay? All right, so let's try the next one. Okay, so for this one, we're now actually going to start multiplying. So you're not going to see a plus sign in between 2 polynomials. You're not going to see a minus sign. You're actually not going to see anything. That's because when you're multiplying in Algebra 1, they're actually going to piece them together so they're right next to each other. And when they're right next to each other, that means that you're going to be multiplying. So for example 5, this should look familiar from what you've done in the past. When I have a number in front of a parentheses, what should we do? We should what? We should distribute. So when you distribute, you're going to take this 3 and you're going to copy and paste it to all of them. So what does that mean? I'm multiplying. So when I multiply 3 times 2n squared, that's simply just going to multiply the two numbers because numbers go with numbers, variables go with variables. So 3 times 2 is 6. So this is going to become 6n squared. Now my next one, I have 3 times 4, which is going to be 12n. And the last one's going to be 3 times negative 3, which is going to be negative 9. And because there's nothing to combine with, there's no like terms, I'm going to go ahead, box in my answer, and I'm done. So every time that you're distributing a number, you're just treating numbers with numbers. Now we're going to look at B. Now B is a tiny bit different because one reason. I'm distributing a 2x squared. Now when I distribute a variable, I need you to remember what we did in the first lesson. What happens when you multiply two variables? What happens to the exponents? You do what? You add them. When you multiply two bases that have exponents, you add the exponents. So what does that mean? I want to make sure that every one of my degrees has a number. What do I mean by that? Put a 1 where the x is. Because when I multiply, I have to multiply numbers with numbers and variables with variables. So you ready? Let's begin. When I distribute the 2x squared to the 4x squared, I know 2 times 4 is going to be 8. But now when I multiply the two x's, I have to remember I'm going to add the exponents. So 2 plus 2 would be 4. So this will be 8x to the 4. Now when I go to my next term, I'm going to do 2x squared times 5x. So again, numbers with numbers, variables with variables. 2 times 5 is 10, positive 10. So I'm going to put a positive 10. And now when I combine the exponents, it's x squared and x1. Remember, add the exponents because you're multiplying. So 2 plus 1 is what? X cubed. And then the last one, there is no variable for the 3, so that's okay. I'm going to multiply numbers with numbers. 2 times negative 3 is negative 6. And the x squared just copies and pastes. And that would be my final answer. So when you're multiplying bases with exponents, make sure that when you're multiplying, you add the exponents of the similar terms. And that's all. Okay. So now what we're going to do is we're going to go to example 6. Now example 6 is a little bit different because there isn't a number in the front. You're actually technically going to multiply. Now, there is an order of when you multiply, but you have to make sure that we're very careful with this, okay? So we're going to draw this out to be a little bit more explicit when we're actually working this out. So the first thing I'm going to do is this. When I'm multiplying, I like to put a 1 where my x's are because I know I'm going to be distributing. And I'm going to go ahead and I'm going to do this. Imagine I were to erase this negative 3. If I were to erase this negative 3, I would literally just have x times x plus 5. So what I'm going to do is I'm going to distribute this x to here. So x1 times x1 again. There's no numbers in front. So it's just technically x times x, which is going to be 1 plus 1. So it's going to be x squared. I'm then going to go ahead and multiply x1 times 5. Again, there's no numbers to multiply, so it just attaches together to be 5x to the 1. Now, I don't really need x to the 1, so I'm just going to leave it as 5x. And that's a positive sign right in the middle. Now, once I do that, I have to remember I distributed the x1 perfectly, but I also have to remember that there's a minus 3 here. So what I'm going to do is I have to remember I now have to ignore everything else. And what I'm going to do is I'm going to cross out the first x, which is going to be crossing this out. So what I'm going to do next is I'm going to distribute the minus 3 to the other parentheses. And then I'm going to put it right next to it. So when I distribute minus 3 times x is just negative 3x. And then the next piece is negative 3 times positive 5, which is going to be minus 15. Now, once I do that, I'm just going to double check that I made sure that I distributed everything, which I hope you agree you did. So because of that, I'm going to combine like terms again. I'm going to look to see if I can combine like terms. And I hope you agree that these two look identical to each other. So I will combine them. So when I combine them, I'm going to go from highest degree to lowest degree. X squared is by itself and 15 is by itself. So I'm going to go from highest degree to lowest, which is going to be x squared, because there's nothing to combine it with. The middle is going to be 5x minus 3x, so I'm going to combine that, so it's just going to be positive 2x. And the last term is going to be minus 15 because there's nothing to combine with. And that would be my final answer. Fun fact, most of the times when you're distributing two binomials, most of the time, you're going to be able to combine the middle. Okay? All right, so let's do B. So again, I'm multiplying. How do I know? Because there's no actual positive or negative operation there, so they're together, which means multiplying. So what I'm going to do is I'm going to distribute the x1, and I'm going to erase this -4 like we did last time, okay? When I distribute it, I'm going to distribute the x1 to both of the outsides as if that -4 never existed, but I know it does. X1 times x1 is going to be x2. Remember, add the exponents. 1 plus 1 is 2. X times -2 is going to be a -2x. And then once I realize that I'm done distributing the first one, I'm going to grab my eraser and I'm going to erase everything I did for the x, and I'm going to do the same exact thing now for the -4. So I'm going to cross out the x, and I'm going to distribute the -4 to everything on the other side. And -4 times x is going to be -4x, and then -4 times -2 is going to be a +8. Now, after I do that, I'm going to ask myself, can I combine like terms? And I can. If you notice, these two look alike again, right? So I'm going to drop down the x squared because there's nothing else that looks like it. I'm going to go in order. -2 minus 4, there's two negatives. What does that mean? You combine them to become what? -6 stays negative with the x. And then the 8 just drops down because there's nothing to attach it with. And that would be my final answer. Okay? So every single time that you're multiplying two parentheses, you have to make sure that you distribute everything and then you combine like terms at the end. Okay? So good job. So now we're going to move on to the next one. Now for this problem, it's a little bit different just because you're going to notice that the setup is a little strange. You're going to notice that you see a parentheses, which is your polynomial, and it's raised to the second. Now, every time that you see this when it's raised to a power, they're really just trying to trick you. All this means is you're going to actually write x plus 3 twice. So you're going to write x plus 3 2 times, and you're going to notice that it looks identical to what you just did on example 6. So what I want you to do is once you notice that pattern, that anytime that you see a polynomial raised to a certain power, just write that polynomial that number of times and you're going to multiply. Now, if you want, pause the video and then try to actually go ahead and multiply by distributing and then press play to see if you got this right. Okay, so what I'm going to do is, since I'm distributing, you already know I like to make this x1, x1. So when I distribute, I'm going to go ahead and again, I'm going to cross out the +3 or cover my finger and just cover it and distribute the x1 to both terms. When I do that, it's going to be x1 times x1, which we said when we're multiplying bases, add the exponent, and it's going to be x to the second power. And then the next one's going to be plus 3x. Now, once I go ahead and do that, my next step is going to be to erase everything I just pretty much did, and I'm going to go ahead and cross out the first x, and I'm going to distribute the +3 with the 2 on the right. So then 3 times x is going to be 3x, and then last one, 3 times 3 is going to be what? 9. Now we said because you're distributing, most often than not, you're going to be able to combine the terms in the middle, which in this case you are. So the x squared comes down because it's the highest degree. The 3x plus 3x becomes 6x, and then the last 9 drops down, and that would be your final answer. So something that looks more complicated actually isn't that bad once you realize you have to write that the number of times out and distribute it out. Okay, so hopefully you got that answer. If you did, great job. If not, I want you to pause the video for B, try it on your own, and then press play when you're ready. So for B, what am I going to do? I'm going to go ahead and I'm going to write this parentheses twice. So when I do that, I'm going to have x minus 4 times x minus 4. And then again, same concept. Cover the first time, but this time I'm not going to cover it. I'm going to trust you. I'm going to distribute x1 times x1, and then that's going to give me x2. x1 times 4 is just going to go together. And then after I distribute the first one, I'm going to move on to my second one. But now notice where I'm going to put it. I'm going to put it underneath so I can go below it. So -4 times x is -4x. I'm sorry, I just made a mistake. I don't know if you guys saw that. So when I do x times -4, it's actually going to be -4x. I wrote a +4 by accident, so luckily I caught that. And then -4 times x is going to be -4x. And then -4 times -4 is what? Is +16. Negative times negative is a positive. So again, I'm going to ask myself, what can I combine? And I'm going to combine the bottom. So it's going to be x squared because it doesn't have anything to combine with. Go highest degree to lowest. Minus 8x plus 16. Make sure you combine your like terms. And then that's it. You're done. So every time that you're distributing, you can try the other method of covering it up, or just remember, distribute every term, every piece. Okay? So now we're going to move on to example 9. Now, I'm sorry, example 8. Now, example 8 looks more complicated, but it's not. It's not. What I'm going to do is I'm going to do the same concept. I'm going to put x to the 1 here, x to the 1 here. And I'm going to distribute the x to how many pieces? Now 3 pieces. So when I do x1 times x2, add the exponents, you're going to get x cubed. When I do x1 times negative 3x1, remember, it's going to be negative 3. And then x1 gives me what? x2. And then I'm going to distribute x1 times 5, which are going to go together as just 5x. Now, next to it, I'm going to go to my bottom piece, and I'm going to do this in a different color. I'll do it in green. And then I'm going to go 2 times x squared, which is going to be positive 2x squared. I'm going to go 2 times negative 3x, which is going to be negative 3x. And then I'm going to go 2 times 5, which is going to be 10. Now, once I do that, my next step is going to be what terms look alike. Because if you notice, it's a lot, but we've already done this. Look for your like terms. So the first one is x cubed. Is there anything that looks like x cubed? There doesn't. So I'm going to move on to my next one. There's a 3x squared. Is there anything that looks like an x squared? There is, a 2x. I'm going to go to my 5x, which is going to be 3 lines, and look for anything that has an x, which is a 3x. And the last piece is a 10, so I'm going to draw 4, but I know there's nothing I can combine it with. So I'm going to go in order from highest degree to lowest degree, so it's going to be x cubed, and it's the only one I have, so I'm going to put it first. I'm going to cross it off because I'm done. I'm going to move on to the 2 lines, which are going to be the x squareds. So I have negative 3x, positive 2. So I got to stick and think about it. Negative 3, positive 2. That's 1 negative, so 1 negative you subtract. 3 minus 2 is 1, and it's going to be negative x squared. But you know we don't write that negative 1, so it's just going to be negative x squared. So I'm going to cross that off. I'm then going to move on to the 5x and then minus 3x. That's simple. 5 minus 3 is 2. 5 is bigger, so it's going to be 2x. And the last number that I have is a 10 that's by itself, and it's going to drop down because there's nothing to combine it with. And that's how I work with that polynomial. Is this difficult? Yes, this is not easy by any means, but you have to stay organized when you work these out. So I'm going to let you pause the video, try B, stay in order, make sure you distribute every single time, and combine your exponents. And when you're ready, press play. Okay, so for B, they try to change it by making it x squared, but that's okay. I'm going to go ahead, I'm going to distribute my x squared to this, to that, and to the last piece, so 3 times. When I do it, x squared times x squared, add the exponents, it's going to be x to the 4. X squared times 4x is going to be, again, put the 1 where the x is, so it helps you out, add the exponents, so it's going to be plus 4x cubed. And then x squared times 2 is going to copy and paste and just be 2x squared. Now, after I do that, I have to make sure I go ahead and distribute all the ones on the bottom, so it's going to be negative 3x squared, or negative 3 to all of them. When I do that, this is what I get. I get minus 3x squared, minus 12x, and then minus 6. And then what I'm going to do is I'm going to combine like terms. So my like terms are going to be x4 and nothing else. 4x cubed and nothing else. 2x squared, and I hope you agree, 3x squared. And then the negative 12x has nothing else, so I'll put 4. And I'm going to get rid of, tired of writing all the lines, but the 6 also gets a line, but there's nothing I can combine it with. So now I'm going to go in order again. X4, there's nothing else that has 1 line, so it's going to drop down. I'm going to go in order, so then this x cubed, there's only 1. So I'm going to drop that down because I can't combine it. So then I'm going to cross it off afterwards. I'm going to go to my next term, which are the x squareds. I could combine this one. 2 minus 3 is negative 1, which again, don't write the 1. Just put negative x squared, and then cross these out because you're done. And then negative 12x has nothing to combine with, so you're just going to drop it down. And the minus 6 also has nothing to combine with, so you drop it down. And that would be your final answer. So whether or not you do the cover method where you cover one and distribute everything out, and then uncover it and then distribute it out, it's up to you what you do, but you want to make sure you distribute it to every single term. Now, after you distribute, make sure you combine like terms, and that's it. Okay, so now we move on to our last example. So now for example 9. Now, example 9, we're actually going to be dividing, but what I want you to remember is whenever you see that there's a monomial, which is 1 term on the bottom, you're actually going to split the bottom. You're going to actually separate it to every single piece. Now, how do we do that? What we're going to do is we're going to split this up by writing it like this. 10x cubed over 5x. And then you're going to write minus 5x squared over 5x plus 20x over 5x minus 10 over 5x. Now, when you break it up, it looks like a lot. It does. But we do this because we like to divide them like we did normally, piece by piece, number with number, letter with letter. The good thing is all these letters are the same. So what I'm going to do is I'm going to put a 1 for every single x by itself so it can help me out. Now, what I'm going to do next is I'm going to go ahead and combine them. So 10 divided by 5, remember, when you see a fraction, write a fraction. So I'm going to draw a fraction. 10 divided by 5 is 2. And then x cubed over x. What do we do when we divide bases? We subtract it. What's 3 minus 1? 2. Where is it bigger? On top. So it's going to be 2x squared. Now, I don't need the bottom because why? I don't have anything on the bottom, so I could erase it. So then the next one, I have 5 divided by 5, which I hope you agree, just cancels out. Remember, when you have the same thing on top and bottom, just cancel it out. And then I have x squared over x. Again, subtract the exponents. 2 minus 1 is what? It's 1. So it's going to be minus x to the 1. Again, you can write the fraction to help you out. Third one, write the fraction. 20 divided by 5 is going to be a positive 5. And then what happens when you have same x's? They cancel out. If not, you can subtract it. What's 1 minus 1? 0. What's 0? What's anything to 0 power? 1. But I'd rather you memorize it like this. Cross them out. So it's just going to be 5 on top, nothing on the bottom. And then the last one, when you see a fraction, write a fraction. 10 divided by 5 is going to be 2. Put it where it's bigger on top. And since the x has nothing to combine with, it's going to stay on the bottom. So the first 3 have no fractions, and the last one does. So my final answer would be written like this. 2x squared minus x, erase the 1 as a power, plus 5 minus 2 over x. And that's how I divide a polynomial with a monomial. So again, how do you do this? You split the bottom, and then you do every piece individually, and then subtract the exponents. So now we're going to move on to our last one. Now for our last one, the bottom actually letter happens to be not an x. It's actually going to be a y. So if you can really quickly for me, just change that to a 3y. And then what we're going to do is we're going to go ahead and split up the bottom. So when I rewrite this, it's going to become like this. It's going to become 3y to the 4 over 3y minus 9y squared over 3y. Now remember, every time you write y to the 1 because it's going to help you out. Plus 18y over 3y minus 6 over 3y. Now remember, if you see a fraction, write a fraction if it helps you out. I'm going to write a fraction. I see a 3 on top, 3 on the bottom. So what happens? They cancel out. I have y4 on top, y1 on the bottom. So I subtract it. 4 minus 1 is 3. So it's y3 on top. I don't need anything on the bottom, so I'm going to erase it, but not now. I'm going to do my next one. See a fraction, write a fraction. 9 divided by 3 is 3, so I'm going to put that on top. And then y squared over y1, I subtract the exponents. 2 minus 1 is 1. Where does it go? It goes on top, so it's going to be 3y. My next piece is going to be another fraction. Draw a fraction. 18 divided by 3 is 6, bigger on top, so keep it on top. I have 2 of the same exact y1s, right? So because of that, I'm going to cancel them out. No reason to subtract because 1 minus 1 is 0. It's the same thing. And then the last one, I'm going to go ahead and draw a fraction, minus sign in the middle. 6 divided by 3 is 2. 6 is bigger on top. And the y1 has nothing to combine with, so it's going to stay on the bottom. So now when I write my final answer, it's going to be y cubed minus 3y plus 6 minus 2 over y. And that would be my final answer. Is this complicated? Yeah. But when you remember that whenever you're dividing by a monomial, which is one term on the bottom, you can split it up so you can divide individually and you get a better answer. So this was definitely a lesson that represented a lot of operations. We did addition, subtraction, multiplication, division. They all have their own rule, but what you need to do is you have to make sure you practice it so you can be better at knowing every single circumstance. So I appreciate you for watching. Best of luck, and I'll see you next time.